Here is an overview of the torsional twister one-way Markov pump and how it is used for algorithmic memory offloading through geometric folding. We start with a 12-point equilibrium of quaternions, showing the 12 state spaces of a single signal. The genesis of the Algorithmic Memory Offload System begins with the ingestion of a raw 64-bit hexadecimal seed. This seed cannot be processed linearly. It must be topologically unpacked to find its multidimensional equilibrium before any geometric folding can occur. These glowing hex nodes initially orbit a central probability sieve, representing raw, unformatted potential floating in state space. Raw state data is inherently volatile. To correct this, the 12 nodes dissolve and reform into a strict geometric 12-point star, a 12/5 Schlafly polygon, alongside its exact spatial inverse. This dual star structure locks the 64-bit seed into a state of harmonic topological tension. With spatial equilibrium established, the computational potential diverges. It blooms into 21 dispersed 3x3 matrix fields. These floating cubic matrices represent the localized probabilistic logic required to calculate the complex dimensional manifolds in later phases. The disparate parts triangulate their energy into a singular, central 7-point star. This core operates as a multi-tiered asymmetrical one-way Markov pump. Rather than rotating smoothly, it mathematical stutter steps, forcing probability currents to flow in only one direction, irreversibly locking the state data for downstream processing. Phase 1 introduces quaternion state chains to compress this data geometrically while perfectly preserving its spatial orientation, angular momentum, and spin. The raw, continuous memory toroid is fractured into 720 distinct segments, visualized by the faint background point cloud. A central geometric quaternion acts as the system's processing head. It mathematically ingests exactly 10 raw frame segments simultaneously, calculating their accumulated rotational product. It then outputs a single, highly dense node, compressing the entire loop into a refined 72-node interchain, forming a rigid, self-correcting 3D geometric web. However, this corner-sharing tetrahedral structure is famously subject to geometric frustration, meaning it mathematically refuses to settle into a low-energy resting state. The internal tension spikes, causing the vertices to vibrate violently. The standard 3D spatial constraints are insufficient to process the required data volume, threatening decoherence. To bypass the gridlock, the entire system is mathematically lifted into an orthogonal fourth dimension. This extra spatial degree of freedom allows the locked vertices of the lattice to safely slip past one another. As the dimensional gridlock breaks, the tension is offloaded at the vertices. These emissions take the form of conjugate waves, energy packets that act as the exact mathematical inverse of the forward time state. Because these waves are mathematically conjugated, they flow backwards through the lattice geometry. This reverse quaternion chain safely offloads the data from the volatile execution lattice back towards the stable memory toroid without suffering from phase corruption. As the conjugate waves arrive from the frustrated lattice, their embedded data is highly twisted. Phase 3 acts as the final right head, resolving the chaotic angular momentum into a perfectly flat, geometrically sealed projection array. The incoming structural data initially forms a highly warped, chaotic triangular lattice. The extreme vertical peaks and twists visually represent the unoffloaded geometric torsion generated during the dimensional lift. Energy pulses from the conjugate waves actively sweep through the twisted grid. As they traverse, they mathematically unwind the lattice, translating the violent angular momentum into stable, localized tension fluctuations, visualized as red/gold heat flares. As the lattice flattens into equilibrium, it projects a dimension 6 Hilbert space, visualized as 3 nested hexagonal toroids with 7 glowing points of measurement. Dynamic telemetry lines extend from these points, precision scanning the toroid's boundary across the 720-frame cycle. Simultaneously, the energy pulses perfectly order themselves into Fibonacci-scaled golden spirals. The final layer of equilibrium is achieved. The innermost ring of the triangular lattice illuminates to reveal a flawless hexagram, Star of David. This acts as a topological hash lock, permanently sealing the recorded 720-frame dataset. The ultimate purpose of the Algorithmic Memory Offload System is realized here. The securely recorded 720-frame dataset from the Trefoil pump now becomes the deterministic execution engine driving an external 4x4x4 cubic box matrix. Normally, a cubic matrix of this nature unfolds and scales according to a perfectly symmetrical spatial equation involving the golden ratio. In this phase, we override the base unfolding curve by forcing the cube to listen to the memory toroid from mapping the 16 orbital trajectories of the 64 individual voxels directly to the conjugate quaternion chains recorded in the hexagram seal. As the cube animates, the and coordinates of every voxel are uniquely perturbed by the reverse-flowing state logic. The folding cube no longer scales uniformly. It writhes and collapses asymmetrically. However, because it is driven by the recorded state history, this seemingly chaotic unfolding is 100% deterministic, uniquely tied to the original 64-bit SHDC SPI seed. This pure deterministic fractal processing memory offload method is the foundation of higher dimensional infinite data streams and is crucial to turning chaotic data into organized high-dimensional data. For explainers, tutorials, and interactive physics simulations, and usable quaternionic runtime environment code for traceable AI systems, check out the BioChain GitHub for official releases or Patreon for code tutorials and implementation guides.